Alright, so here we are back to take a look at the homework for 8.2. And so the first one that we're presented with, we've got AX, then BX, BX, then CX, AX, then CX with universal quantifiers. So we have to get rid of those quantifiers with the universal instantiation. So whatever letter you choose to put in here is fine. I'm going to use S, I think. So if AS, then BS from 1 universal instantiation. And then line 2 becomes BS, then CS from 2 universal instantiation. And then 5, we've got a hypothetical syllogism here. If AS, then BS, if BS, then CS, therefore if AS, then CS. All right, 3, 4 hypothetical syllogism. And that's basically what we're looking for. All we have to do is change it back by doing a universal generalization. So we'll add the quantifier, and that becomes AX, then CX from 5 universal generalization. Okay. Number 2, we've got X, BX, then CX, EX, AX, and BX, EX, AX, and CX. All right, so this is actually kind of like the one that we did for practice there. Again, there's no specific letter being given to us, so we can use whatever letter you choose to put in there. Let's use D. So how about we make that BD, then CD, 1 universal instantiation. And then 2 becomes AD and BD from 2, and that's an existential instantiation. Then here I am going to simplify and make line 4 AD from 4 through simplification. And then I'm going to go back to 4 and make that BD, again through simplification, basically putting both sides on 2 separate lines. Now lines 3 and 6 make a modus ponens. If BD, then CD, BD, therefore CD, 3, 6, modus ponens. And so now we've got AD and CD on 2 separate lines. We want to put them together. So we'll have AD and CD from 5 and 7 as a conjunction. And since it wants it in that form, we'll do an existential generalization. Add the quantifier, replace the D with the X, and then that's an existential generalization. And just like that, number 2 is done. Number 3, we have on line 1 the universal quantifier AX, then BX. On line 2 is not BM. Therefore, the conclusion, existential AX and CX. Okay. Now with this one, since we've got BM, we know that M is what we're going to want to be replacing the X with. So we'll do a universal instantiation, and that becomes AM, then BM from line 1, universal instantiation. And now 2 and 3 would make a modus tollens. If AM, then BM, not BM, therefore not AM. 2, 3 modus tollens. All right. Wait a minute. Oh, okay, I miswrote that. No wonder that doesn't make sense. There's no C in it, is there? So it should be not AX. That makes a lot more sense. I've told you before, copying these right is the hard part. The conclusion you're actually looking for is existential, not AX. Okay, so there, that makes it a lot easier. So we take the AM, we do a existential generalization, add the quantifier, replace the M with the X, and so just like that, existential generalization, we've got our answer. All right, yeah, it's a lot easier when you copy them down right. All right, so number 4, we've got x, ax, then bx. Line 2, we have y, ay, or not by. And the conclusion is x, ax, if and only if bx. Okay. So here's another one of those where they're trying to trick you by having the x and y both being used, but again, just replace them with the same letter and you should be fine. So whatever you want to use, I'm going to use, I think, G this time. So on line 3, we'll replace the first one here. We'll make that AG, then BG from line 1 through universal instantiation. And then we'll also replace Y with G, and this will become AG or not BG from 2, universal instantiation. From here, then we just go on to solve it. Now, this is one of those instances where maybe you can visualize it, but it might be easier to actually use commutativity and make this not BG or AG, because then you'll be able to see the setup a little bit better, because that gives you a material implication which would make it BG then AG. From line 5 through material implication. Now, if you'll notice, we want to get to the triple bar, right? An equivalence. Well, that means that one of the things that would do would be what we have right here. AG then BG and BG then AG, right? Two conditional statements working both directions. So let's use a conjunction to stick those together. So AG then BG and BG then AG from 3 and 6 conjunction. And now this would give us AG if and only if BG from line 7 through material equivalence. And since they want it in that format, we're going to add the universal quantifier back in, replace the G with the X, and that was from line 8 through a universal generalization. And that one is done. Number 5, we have x, ax, then bx or cx. Line 2 is AG and not BG. Therefore, CG. All right, so with this one, since we've got G given to us there, we're going to do the instantiation based on G up here. So that becomes AG then BG or CG from line 1, universal instantiation. And then we start solving. So on line 1, AG and not BG, let's simplify that to make it AG. And that would leave us through lines 3 and 4 with a modus ponens, AG then BG or CG, AG therefore BG or CG from 3, 4 modus ponens. And now we want to get to CG, so we'll go back to line 2, do simplification the other way to get the BG. And now 5 and 6 make a disjunctive syllogism. It's either BG or CG. It's not BG, so therefore it is CG. 5, 6, disjunctive syllogism. And of course, since that's what they asked for, there's no need to do a generalization on it because you've reached the conclusion that you were asked for. All right, number 6, we have x, ax, or bx. then CX. Line 2, we have EY, AY, and DY. Therefore, EY, CY. Okay. So once again, we've got x and y as our variables, but just replace them with the same letter, whatever letter you choose to use. Let's use R this time. So we'd have AR or BR, then CR from line 1, universal instantiation. And line 4 would become AR and DR from line 2, existential instantiation. And then we just go ahead and solve. So I'm going to take line 4, AR and DR, and simplify to make it AR. And then we want AR or BR, right, because it's the CR we're going to want. So using addition, you can add anything you want. So we're going to add a BR to that. And so now 3 and 6 make a modus ponens. AR or BR, then CR, AR or BR, therefore CR. 3, 6 modus ponens. And since they want that form with the y as the variable, we'll do a existential generalization with the y. CY from 7, existential generalization. And there's that one done. So hopefully you're finding these to be fairly easy once you get past the instantiations and whatnot. We did 7 in the example earlier, so we just skipped to number 8 now. So x, AX, then BX or CX. Line 2, we have EX, AX, and not CX. And the conclusion we want to reach is EX, BX. Okay. So again, no specifics here, so translate for whatever letter you choose to use. How about F this time? AF, then BF or CF. Line 1, universal instantiation, and AF and not CF from line 2, existential instantiation. And so then we just start solving. Simplify line 4 to AF, and then 3 and 5 make a modus ponens. If AF, then BF or CF, AF, therefore BF or CF. 3 and 5 modus ponens. We want to get to basically BF, all right? So right here on line 4, you've got not CF, so we're going to take that through simplification. And so 6 and 7 make a disjunctive syllogism. BF or CF, not CF, therefore BF. And since they want that form, we're going to do an existential generalization. And number 8's done. Number 9, we've got x, AX, then BX. Line 2 is AM and AN. Therefore, BM and BN. All right, this one tries to be a little bit tricky too because they've given you 2 letters. But the thing is that x is a variable, so it can stand for both of those. So what I would do right to the start, I'm going to use a universal instantiation on line 1, make that AM, then BM. Line 1, universal instantiation. Then we'll go to line 2 and simplify to make that AM. And now 3 and 4 make a modus ponens. If AM, then BM, AM, therefore BM. 3, 4 modus ponens. and that's half the equation. Now go back to line 1 and instantiate again, this time using the n. So an, then bn from 1, universal instantiation. And then go back to line 2 and simplify the other way to get the an. And so 6 and 7 again are modus ponens. If an, then bn, an, therefore bn. And since we want bm and bn, bm is on line 5, bn is on line 8. Just use conjunction to stick those together. And you're done. All right, and finally, number 10, we have x, ax, then bx. Line 2, am or an. Therefore, bm or bn. Once again, we've got the m and the n, so we're going to instantiate twice. And when you do, you'll see how very easy this one actually is. So the first time we're going to use m. This becomes am, then bm from line 1, universal instantiation. And then we'll do it again using the n. an, then bn from line 1, universal instantiation. All right. Well, now, if you think about it, you've got two conditional statements. Your second premise here, am or an, are the two antecedents joined by the wedge. And the conclusion that you want to reach, bm or bn, are the two consequents joined together by the wedge. So basically, we're looking at a constructive dilemma. To make it look like a proper constructive dilemma, you're going to need to do a conjunction on 3 and 4. So am, then bm, and an, then bn from 3 and 4 as a conjunction. And then, just as we saw a moment ago, 2 and 5 will give you your answer, bm or bn, through a constructive dilemma. Okay? And that's basically all there is to it. So hopefully you guys did well on that. And incidentally, even though we didn't go any further in the text due to the circumstances and whatnot, if you were to go on, you would see that there is a section dealing with conditional proof. And basically, just as we learned in the last chapter, conditional proof would work exactly the same way too, except that you would need to do the instantiations or generalizations in the predicate logic in order to be able to work with it. But other than that, it's perfectly the same. All right. So anyway, I hope you guys have done well on these and have enjoyed the class, even after we've had to go to this format. But in any event, if you have any questions, let me know. But otherwise, have a great day and best of luck on everything.